Now I will tell you what is a prime number. Everybody knows what is a prime number, what is a composite number. Okay. 2 is a prime number. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Okay. You know the prime numbers up to 20. That means you know the prime numbers up to infinity. Okay. I can understand that. You know the concept of prime numbers up to infinity. A natural number p is said to be prime when p is greater than 1 and its only divisors are 1 and p. A natural number that is not prime is called a composite number. Every composite number can be written as a product of prime numbers. Every composite number can be written as a product of prime numbers. For example, 6 is a composite number. It can be written as a product of 2 prime numbers called 2 and 3. Similarly, 10 is a composite number. Can you write 10 as a product of 2 prime numbers? Can you answer? Can you write 10 as a product of 2 other numbers, 2 prime numbers? What are the prime numbers? 2 and 5. So, there is a theorem called the unique factorization theorem. Every composite number can be written as a product of prime numbers and that factors are unique only. They can be coming in different order. Instead of 2 and 3, 2 into 3 equal to 6 or 3 into 2 equal to 6, you can say. Only the order will change, but the factors are unique. That theorem is called unique factorization theorem or fundamental theorem of algebra. Fundamental theorem of algebra, what it says in number theory, that is the first theorem. So these are all prime numbers. The fundamental theorem of arithmetic is every natural number larger than 1 can be expressed as a product of prime numbers. So the factorization can be done in any ways. For example, 30 it is a composite number. It is expressed as a product of 2, 3, 5, 3, 2, 5, 5, 2, 3, but same factors in different order. Only the order will change, but the factors are unique. That is why this theorem is called unique factorization theorem. Suppose you are asked to find whether a given number is prime number or not. You are given a number 101. It is prime number or a composite number? How did you know that it is prime number? Okay, 91. It is a prime number or a composite number? 91 is a prime number or a composite number? Composite number. 81? 71? Prime number. Okay. Now, how do you understand something is a composite number, something is a prime number? Divisible by some other number. 91 means 7 13s are. 81 means 9 9s are. Or 3 3 3 3, 3 power 4 equal to 81. By that you are able to find some factors. If you want to check whether some number is a prime number, you are asked to write a computer program. Suppose 101. To check whether 101 is a prime number, with what numbers and with what and all numbers you will divide 101. So to divide 101 with many numbers and check. With how many numbers you will check. I want to check whether 10 is a prime number. With how many numbers you will check. Even number means one time you can. Odd number means we don't know. Okay, 343. It is a composite number or prime number? Composite number. But it is divisible by 7. But you have to find out when you write a computer program, we don't know which number will be given. Any number will be given. So you have to check up to the worst case behavior is up to previous number you have to try. Suppose 11 you want to try, up to 10, 2, 3, 4, up to 10 you can try. The better algorithm is, the 2 if you try, don't try with 4, 6. So once you check whether it is a even number. If it is not a even number, then try with 3, 5, 7 like that you will be going and try. Up to what number you have to try. Suppose there is a number 11, up to what numbers you will try. Up to 5 it will be sufficient. Why it is sufficient is 11 divided by 2 will be around 5.5. So up to 5 it will be okay. That is one algorithm. And the best algorithm will be up to square root of that number. If you try, that is sufficient. For example, what is the square root of 100? 10. So if you want to check 99 is a prime number, or 97 let us say. 97 is almost 100. Square root of 100 is 10. So up to 10 if you are trying, that will be sufficient. Up to square root of that number. That is the best algorithm. So for checking, either you can go for dividing with half of the numbers, you can go for checking how many numbers are there up to before that number you can go, that is one way. Number of iterations, after iterations, half the numbers are square root of that number. By this different algorithms are there. The most efficient algorithm is to the square root of that number you have to check. Now I will define what is meant by relatively prime. Two numbers are said to be relatively prime. Their greatest common divisor equal to 1. What is the greatest common divisor between 4 and 6? So according to this definition, if the greatest common divisor is 1, they are relatively prime. Therefore 4 and 6 are not relatively prime. 4 and 7 let me take. What is the greatest common divisor between 4 and 7? 1. Therefore 4 is relatively prime to 7. So prime is different. Prime number concept is different. Relatively prime is different. Relatively prime means co-prime, another word. Co-prime or relatively prime are the same. You have to see the greatest common divisor. Its meaning is number of numbers less than n and that is phi of n. Phi of n, there is one highest phi function. That highest phi function will find number of numbers less than n and relatively prime to n. Less than n and relatively prime to n. For example, number of numbers less than 7 and relatively prime to 7, how many numbers? What are the numbers relatively prime to 7? 1 and 7 are relatively prime. 2 and 7 are relatively prime. 3 and 7 are relatively prime. 4 and 5, 4, 5, 6, up to that number. So number of numbers less than n means less than 7 and relatively prime to n. Therefore it is 6. For a prime number it will be n minus 1. 7 is a prime number, therefore n minus 1. N minus 1 means 6. For 11 it will be 10. For 17 it will be 16. Phi of 17 equal to 16. But phi of 35 if you want to find. How will you find phi of 35? Phi means highest phi function. It indicates the number of numbers less than n and relatively prime to n. So phi of 35 if you want to find, 35 should be expressed as a product of two prime numbers. So 35 equal to 5 into 7. What is the phi of 4? Phi of 5? 4. And the phi of 7? 6. 4 into 6. So phi of 4 into phi of phi of 35 equal to phi of 5 into phi of 7 You understand how to find the Euler's phi function value? Euler's phi function. Euler's phi function defines that a number of numbers less than n and relatively prime to n. I am taking n equals 35. So the number of numbers less than 35 and relatively prime to 35, if I am taking, one is 35 if you are counting, one is relatively prime to 35, yes, 1, 2, yes, 3, yes, 4, 5, no, then 6, yes, 7, no, like that if you are counting 24 numbers. So multiplicative inverse. In the real number system, every non-zero number has a multiplicative inverse. A number you must multiply to give a number 1. What is the multiplicative inverse of 5? 1 by 5. Similarly, multiplicative inverse of 7, 1 by 7. Additive inverse of plus 5, minus 5. So you understand the difference between additive inverse and multiplicative inverse. So in the modular arithmetic, a multiplicative inverse may or may not exist, depending upon the following fact. Therefore, if the greatest common divisor between a number b and m equal to 1, then b inverse exists. Modulo m when you do modulo m, if the greatest common divisor between b and m, b is a number you are taking, you want to check whether b is having inverse in the modulo m algebra, then the greatest common divisor between b and m must be 1. If it is so, there is a b inverse exists. So greatest common divisor of two numbers is the greatest positive integer that divides each of the integers. For example, the greatest common divisor between 12 and 8 is the greatest common divisor between 12 and 8 is 4. Now, how do they find this? You find the divisors of 12, divisors of 33. To find the greatest common divisor between 12 and 33, the common divisors are 1 and 3, multiply them to get the greatest common divisor. Here, the divisors are 1, 5, 25. Here also 5, 25, but the common divisors are 5 and 25, the greatest common divisor is 25. The meaning of greatest common divisor is, even though 5 is a divisor and common divisor, 25 is a common divisor, both 5 and 25 are common divisors, but the greatest amount 5 and 25 is 25. That is why 25 is called greatest common divisor. Between 8 and 12, 2 is a common divisor, 4 is a common divisor. Which is the greatest common divisor? 4. Here the greatest common divisor is 1. Now, the simplest method to find the greatest common divisor is, I can write an algorithm. While x is not equal to y, if x is greater than y, then x equal to x minus y. Else y equal to y minus x. This algorithm is called Euclidean algorithm. Or GCD between x and y. Let me take 4 and 6. You see this algorithm. I want to find the greatest common divisor between 4 and 6. I am taking the Euclidean algorithm. The first step of the Euclidean algorithm is while loop. While x is not equal to y. 4 and 6. X is not equal to y is satisfied or not satisfied? Not satisfied. Sorry, satisfied. Therefore, I can go inside the if statement. Inside the if statement, if x is greater than y, you have to come to the first if part. If x is not greater, you have to come to the then part. We will be going to if part or else part. Else part. So if you come to else part, y equal to how much will come? 2. So x equal to 4, y equal to 2 now. X equal to 4, x, y, 4 and 2. Now let us start once again from the while loop. X is not equal to y is satisfied? Satisfied. If x is greater than y is satisfied? Yes. Therefore, what we have to come to if part or else part? If part. So x will become 2. So now x becomes 2, y also becomes 2. Therefore, we are getting x2, y also 2. X also 2. X also 2, y also 2. Now you check x is not equal to y is satisfied? X is not equal to y is satisfied? No. When everything is over, you have to write return x or return y. Anything is okay. So I did not write that statement. Last statement should be return x or return y. So return x, 2 will be returned. That is the greatest common divisor. This is the simplest algorithm. It was proposed by Euclid. So this algorithm is called Euclid's algorithm. Many algorithms are there. Even Euclid's algorithm, we have different formats. I am giving the basic format. It is by subtraction method, they say. Different methods are available. We will study the different algorithms given in the number theory. Another method, you see the algorithm, first take the two of the given numbers, divide the greater by the smaller number, then divide the divisor by the remainder. The divisor which does not have leave a remainder is the greatest common divisor. To the time we get 0, that is, the remainder should be 0. When you get the remainder 0, up to that time you are going on. You see the method. First, we want to find the greatest common divisor between 1785 and I46. We divide the bigger number with the smaller number first. If you divide the bigger number 1785 with the smaller number 546, the remainder is 147. You have to repeat this process up to the time you get a remainder equal to 0. Now we are getting remainder equal to 147. You take 147 as the divisor and 546 as the dividend. You will be taking 546 as the dividend, 147 as the divisor. Divide once again. You are getting the remainder 105. Now 105 will become the divisor, 147 will become the dividend. Divide again, you will get 42 remainder. 42 will become the divisor, 105 will become dividend. Divide, you are getting 21. Now 21 is becoming the divisor, 42 becoming the dividend. Divide, you are getting 0. That means the last divisor is the greatest common divisor. The last divisor is 21. Now 21 is the greatest common divisor. This is the same like Euclidean algorithm only. It is called the division remainder method. The division remainder method, you will be changing only the divisor and the divider every time. First time what your remainder you are getting, that will become always a divisor. This remainder becomes a divisor. This remainder becomes a divisor. This remainder becomes a divisor. Then the divisors, how you are changing is, the divisor here will become the dividend. Next divisor will become dividend. Divisor become the dividend, and so on. One more example. 48 and 60. It is with the 12 you are getting 0. So the divided greatest common divisor between 48 and 60 is 12. Is it okay? Now, greatest common divisor between three numbers. You find the greatest common divisor between first two numbers. Then use that number as one of the number and the other number, that number as another number. You find the greatest common divisor between these two numbers. You will be getting the greatest common divisor between three numbers. You see here, first we take 48 and 60. The 12 is the greatest common divisor. Now between 12 and the third number 38, 12 and 38 I am starting. 12 and 38 if I start, it becomes 12 remainder with 2 times, here 2 is the remainder, 12 will be coming here, we are getting 0, so 2 is the greatest common. This example shows the method of finding greatest common divisor between three numbers. I can move. Now, divisibility. Let A, B and M be any integers. A non-zero number B divides A if A can be expressed as a product of M and B for some M. That means A divided by B equal to M. If B divides A, then there is no remainder. That means we write B divides A means B divides A and there is no remainder. We say that if B divides A, then B is a divisor of A. One example, 5 divides 10. 5 divides 10 or not? 5 divides 10. Therefore, pi is a remainder. Pi is a divisor of 10. 5 divides 15. 5 divides 16. Okay. So, the concept is like this. If A divides B, then, B divides A, then B is a divisor of A. A divided B, B equal to M, you can write A equal to MB. Let me take A by B equal to M means 10 by pi equal to 2, 10, A equal to 10, B equal to 5, M equal to 2. Now you can write 10 equal to 2 into 5. Suppose A equal to 10, B equal to 5, A divided by 10 divided by 5 will be 2, 2 equal to M. That means A equal to 10, B equal to 5, M equal to 2. We can write 10 equal to 5 into 2. A equal to B into M. This is what. Now divisibility property. If A divides 1, then A should be either plus 1 or minus 1. Then only A can divide 1. Which number will divide 1? Which number can divide 1? Either 1 or minus 1. why? If A divides 1, then A equal to plus or minus 1. If A divides B and B divides A, then A equal to plus or minus 1. Then if B is not equal to 0, divides 0. Any number which is not equal to 0 can divide 0. But 0 will not divide 0. Why 0 will not divide any number? It will become infinity. Next step. If A divides B and B divides C, then A divides C. You understand? You accept it? A divides B, B divides C, then A divides C. Let me take example. 5 divides 10, 10 divides 100. It means that 5 divides 100. 11 divides 66 and 66 divides 198. It indicates that 11 divides 198. If B divides G and B divides H, then B divides mg plus nh for arbitrary integers m and n. To see this, we will have a proof. If B divides G, then G can be written as G equal to B into some G1. Okay. You understand? B divides G means which one is bigger? B divides G means B is bigger or G is bigger? G is bigger. So G can be written as B into something. Okay. We write G equal to B into some G1. Similarly, B divides H, then H is of the form H equal to B into some H1. So we can write mg plus nh equal to, we want to bring to this one. We want to prove this. I want to prove that B divides mg plus nh. I write mg plus nh equal to, mg means m into g. G is bg1, m bg1. Next nh. nh is n into bh1. In both the things, if you take b outside, it becomes mg1 plus nh1. In general, it can be m into some g plus n into some h. Therefore, if b divides g and b divides h, we can say that b divides some mg plus nh or arbitrary integers m and n. We have written the proof, but the theorem statement is more important in number theory. If you have any doubt in the proof, I can explain you again. Check if you are able to understand. Shall I proceed? So one example for the same thing. B equal to 7, G equal to 14, H equal to 63, M equal to 3, N equal to 2. We are going to prove this. B divides mg plus nh. First we take G and H in such a way that B divides G, B divides H. That means we are taking multiples of B only for G and H. You see the values of G and H, it is multiples of 7. We take B equal to 7, G will be a multiple of 7, H is a multiple of 7. That way we have taken. That is why we say that B divides G, B divides H. When you want to say that B divides G, G is a multiple of B. 7 if I take, 7 divides 14, 7 divides 21, 7 divides 63. Therefore, I am taking G and H values from multiples of 7. To show that 7 divides 3 into 14 plus 2 into 63, we have 3 into 14 plus 2 into 63 equal to 7 into, you are taking common factors from both this. This 14 is written as 2 into 7. 63 is written as 7 into 9. We want to write multiples of 7. You see, 14 is written as a multiple of 7 as how we are writing. 14 will be 2 into 7. 63 will be 9 into 7. That 7 we are taking it out. So 9 we are keeping out here. Similarly in the 14, 2 we are keeping here. 7 we are taking out. So 7 divides a multiple of 7. We say that 7 divides 7 into something. Definitely 7 will divide a multiple of 7. This is the proof. Any doubt? This algorithm is called division algorithm. Suppose you are having 11, you are dividing with 4. What will be the remainder? Three will be the remainder. Now, 11 was the dividend. You divided with 4. How many times 4 it is going? 2 times. That is the quotient. Now, divisor into quotient is how much? Divisor is 4, quotient is 2, 8. So divisor into coefficient plus remainder equal to what? Dividend. So dividend equal to divisor into quotient plus remainder. That is called division algorithm. I will tell what is division algorithm. You see this? Given any positive integer n and any non-negative integer a is the dividend. If we divide a by n, that means a is the divisor. We get an integer q is the quotient, and remainder r. It obeys the relationship a equal to dividend equal to quotient into divisor plus remainder. This algorithm is called division algorithm. Division algorithm says that dividend equal to divisor into quotient plus remainder. Now we can write a equal to 11, n equal to 7. 11 can be written as 1 into 7 plus 4. Since if we divide 11 with 7, we are getting quotient 1, remainder 4. So remainder equal to 4, quotient equal to 1. The next case, a equal to minus 11. Here the remainder equal to 3 and the quotient equal to minus 2. The division algorithm, n, 2n, 3n, qn, q plus n, like that if you have. Now the n will be having the duration of qn to q plus n, and the remainder will be here and all 1 time, 2 times, 3 times, like that n, q times it is quotient times it will go. After quotient times, what is remaining, that will be called remainder. For example, 11, you are dividing with 7, 3 let us take. How many times it will be going? 3 times. After that, what is remaining is 2. So 3 times will be coming up to this place. 1 time, 2 times, let us say this is 3 times. It is 4th time. 4th time it will not go. So the remainder will be coming in between. 3rd time plus something. The same thing is only 15th. 1 15 is 15, 2 15s are 30, 3 times, 4 times, 5 times it will be 75, but we have only 70. 70 divided by 15. In 70, how many 15s are there? In 70, how many times 15 will go? 4 times it will go. So up to 4th time it is going. But 70 we have, remaining 10 will be called the remainder. Euclidean algorithm is used to find the greatest common divisor between two numbers. Euclidean algorithm works like this. It is one form of Euclidean algorithm. I told using subtraction, using division. First you check if A is greater than B. Yes means divide A by B. If A is not greater, swap A and B. You have to divide the greater number with the smaller number. If A is greater, start dividing A with B. A divided by B. If A is not greater, swap A and B. After that you do the division. Now divide A by B, calling the remainder R, check whether remainder is greater than 0. If it is yes, then greater than 0 means replace A with B, replace B with R, divide once again up to the time R is greater than 0. When R is greater than 0 is not satisfied, then the greatest common divisor of A and B is the B. This is the algorithm. Let me take an example. A equal to 6, B equal to 4. A is greater than B? Yes. So where I will come? I will come to swap part or divide part. I will come to swap part or divide part. Divide part. So divide A by B, calling the remainder R. Remainder R equal to 2. You check R is greater than 0. R is greater than 0? Yes. If it is so, replace A with B. That means A equal to 4. Replace B with R. B equal to 2. Once again divide A by B. If you divide A by B, the remainder is, how much is coming? 4 divided by 2, remainder is 0. R is greater than 0. R is greater than 0? No. So now means greatest common divisor is final value of B, that is 2. This way, you can find the greatest common divisor between two numbers using this Euclidean algorithm. Previously I was using subtraction. This is division. In computer, what is the relationship between subtraction and division? Is there a relationship between subtraction and division? Repeated subtraction is equivalent to division. Similarly, repeated addition is equivalent to multiplication. Suppose you want to multiply 5 4s are 20. For us it is looking easy. For a small child, you want to teach 4 times 5. How will you teach? 1 time 5, another time 5, another time 5, another time 5, and add them. So, first time, put 5 rounds. Second time, put 5 rounds. I said 4 times you will ask the child to put 5 rounds. And you will ask the child to count after 20 rounds. It will be 20. That means repeated addition will become multiplication. Repeated subtraction will become division. So the Euclidean algorithm which I explained earlier was using subtraction. Now the same Euclidean algorithm is using division for doing the operations faster. Now we want to check quotient. A is the dividend, B is the divisor, R is the remainder. We want to find the greatest common divisor between 12 and 33. Bigger one is A, smaller one is R. Now divide the bigger one by the smaller one. What will be the quotient? 33 divided by 12, what will be the quotient? How many 12s are there? 33. 2 is the quotient. What is the remainder? 9. So we are writing the quotient as 2 and the remainder as 9. Quotient is 2, remainder is 9. Next step, we will change, the remainder will become B and the divisor will become dividend. So B is becoming A, R is becoming 9. You divide once again. So 12 divided by 9, what is the quotient? 12 divided by 9, quotient is 1. Remainder is 3. So we are writing that. Like this, if you proceed, finally you are getting 0. Now the final B value is the greatest common divisor. The final B value which is not 0. So which is the greatest common divisor? 3. This is 3 is the greatest common divisor. Similarly, it is done for greatest common divisor between 900 and 750. The same process it is repeated. Finally, 750 divided by 150, it is 5 times 750 is 150. 5 times 150 is 750. Remainder is 0. So 150 is the greatest common divisor between 900 and 750. Here it is 21. Able to understand? Now we will develop an algorithm based on Euclidean algorithm only. We are not developing. We developed, we are understanding. Okay. Divisor equal to dividend equal to divisor into coefficient plus remainder. This is only division algorithm. A equal to BQ plus R. A is the dividend, B is the divisor, Q is the quotient, R is the remainder. A equal to BQ plus R. That is only division algorithm. Next time, B will become the dividend and R will become the divisor. A new remainder will come. New quotient, new remainder will come. You see the procedure which we followed in the earlier one. Same thing. B will come here, R will come here, new quotient, new remainder will come. Next time, this R will come here, R1 will come here, R2 and Q2 will come. Like that, if you are going on repeating, you will be getting a generalized algorithm. Using that algorithm, the greatest common divisor between 34 and 55, it is found. You check whether you are able to understand. This is the last B. Last B. B will become, this B is becoming left side. It is 1. The formula is derived like this: A equal to Q1B plus R1, B equal to Q2 R1 plus R2, R1 equal to Q3 R2 plus R3. Like that, it will be going on. If you understood that, you can understand this. You check whether you are able to understand this. What is the problem here? Greatest common divisor between which numbers we are finding? 1160, 718, 174, and another number is 316, 258, 250. We are using the same formula. A equal to Q1B plus R1. Next B comes here, R1 comes here. Like that we are repeating. finally the greatest common number is 1078. Anybody has doubt in this? This is also similar thing. I will write into the same thing which is written as an algorithm. Euclidean algorithm, repeated division method, it is converted into an algorithm. We will take a small example I will take, or bigger example I will take. Bigger number or smaller number? Smaller number will be easier for understanding. So I will take smaller number. I take 12 and 8. What answer you expect? What answer you will take? I want to find the greatest combination between 12 and 8. What is the answer? 4. 4 we know the answer. So I work out based on this algorithm. R1 equal to 12. R2 equal to 8. You check whether R2 is greater than 0. While loop I am coming. While R2 is greater than 0. It is satisfying. Quotient equal to Q equal to R1 divided by R2. How much will come? Integer division. 12 divided by 8. What will be the 1? And R equal to R1 minus QR2. How much is QR2? To find QR2 first. Q is how much? 1. R2 is, QR2 is 8. The second line, R equal to R1 minus QR2. R1 is 12. So if I find R equal to R1 minus QR2 equal to R1 is 12 minus Q is 1 into R2 is 8 equal to 4. Anybody did not understand this step? I am in which step? Inside the while loop I am in which step? R equal to. What is the next step? R1 equal to R2. So R1 equal to, currently R2 is 8. R2 equal to R. R is how much? 4. Now you check while R2 is greater than 0. Is R2 is greater than 0? Yes. So Q equal to R1 divided by R2. How much will come? 2. R equal to R1 minus QR2. That is 8 minus 2 into R2. 0. R1 equal to R2. 4. R2 equal to 0. You check R2 greater than 0. You check the condition R2 greater than 0 or not greater than 0? Not greater than 0. So we are coming down. Which value we are going to return? R1. What is the value of R1 now? 4. So 4 is the greatest common divisor between 12 and 8. Check whether you are able to understand this algorithm. I am writing the example. If you follow the steps of the algorithm, for these two numbers, 2740 and 1760, Q, R1, R2, R, if you are going on separating, you see the simulation. First, R1 equal to A, R2 equal to B. So what will be A and B? R1, R2. R1 is 2740, R2 is 1760. Next step is Q equal to R2 divided by R1 divided by R2. So Q, how much times it will go? Q is equal to R1 divided by R2. One time it is going. What is the remainder? 980. Next time, this 980 is become R2, 1760 is becoming R1. Repeating, finally we are getting 20. 20 is the greatest common divisor. It is an example for the algorithm. Now we are extending the Euclidean algorithm to find the multiplicative inverse also, it will be useful. If you follow the Euclidean algorithm in this format, you can check whether multiplicative inverse is there. To find the multiplicative inverse, this format of algorithm. So you see the algorithm, first R1 equal to A, R2 equal to B. We are introducing 4 more variables, S1 equal to 1, S2 equal to 0, T1 equal to 0, T2 equal to 1. With this, if I am proceeding, now I want to find the greatest common divisor between, once again, R1 equal to 12, R2 equal to 8, S1 equal to 1, S2 equal to 0, T1 equal to 0, T1 equal to 1. Now you check whether R2 is greater than 0. R2 is greater than 0, or what is the R2 now? 8. It is greater than 0. Therefore, Q equal to R1 by R2, it is 1. R equal to R1 minus QR2. QR2 will be 1 into R2, 8. R1 is 12. 12 minus 8 is 4. It is like previous algorithm. Next, R2 is assigned to R1. That means R1 equal to 8. R2 is R. So R2 equal to 4. These two algorithm, we are changing R1 and R2 role. After this, S equal to S minus Q S2. That means 1. S equal to S1. S1 is 1 minus Q S2. S2 is 0. So Q S2 is 0. S1 equal to S2. So previous S2 it is 0. S2 equal to S. So S is assigned to S2. That means 1. T equal to T1 minus T1 is 1. T1 is 1 minus Q T2. Q into T2 is 2 is 1. T equal to T1 minus 0 minus Q T2. That is 1. T equal to minus 1. I got this. Next, while R2 is greater than 0, to check whether R2 is greater than 0. Yes. So R2 is greater than 0 means Q equal to R1 divided by R2. Right now R1 is 8 divided by R2, it is 2. R equal to QR2. QR2 means 2 R2. 2 R2 means R2 is 4, 8. R equal to R1. Right now R1 is 8 minus QR2. Q is 2 into R2, 4. It is 8. Now R1 equal to R2. Right now R2 is 4. R2 equal to R. It is R2 equal to R means what is R0? S equal to S1 minus QS2. QS2. Q is 2, 1, 2. S1 is 0 minus 2, 2. S1 is S1 equal to S2. S2 is 1. S2 equal to S. So S2 equal to minus 2. T equal to QT2, 2 into T2. How much is T2? 1. 1. Q is 2 into 1. T1 is 0. 0 minus 2. Now, greatest common divisor is R1. So, greatest common divisor is right now R1. And inverse. So, this extended Euclidean algorithm, they will use to find the inverse also. I did not take an example, but among this S and T, last two values, one among them will be the inverse. What is naming is S equal to S1, S equal to S1, S1 is how much 1, S2 equal to T1, T equal to T1, T1 is how much 0, and this one, okay. So right now, we did not apply the algorithm for finding the inverse, we found only the greatest common divisor, but this algorithm, you can use it to find the inverse also. In this simulation, any doubt? It is another comment, but we are using the built-in function. In Python, even for matrix inversion, when I was giving the lab examination, that matrix inversion 4 by 4 I have given. The people who were writing programming C and Java, they were taking more than 1.5 hours. The people who used Python, they call the built-in function. Before I stopped giving the question paper, they finished. The logic is same. Python, they are using the logic, they are writing the program. For library functions, how the library functions are made. If you are using a library function, we can finish it fast, definitely. When you go to the industry, they will allow you to use the library function. But when the whole project is stuck up, they will call the engineers, and there may be some art students also. They can use the library function without explanation. But you will be put as a leader, team leader. You have to explain why this goes wrong. So you have to take the algorithm again. You have to work out and say that because of this part, it does not have a inverse, therefore this algorithm will not work. So you have to go for another way. That explanation you have to do. So all the engineering students, not only using the library function, they must know how it is working out. If you are an engineer, you will learn this. If you are, which course you are doing now, detect means you should learn this. Okay. If you are doing BSc, take it good, no problem. Okay. So nowadays in Python, almost everything is built in. Even before that, in Fortran, when in the 80s I was using Fortran, there itself there was a library called NAC library. In that you can find the solution of simultaneous equation, solution of even nth order differential equation, everything. But we were asked to do once again. The reason is, we are putting, I was working for nuclear submarine. After putting into the submarine, if I am calling the library function, purposefully the person who is making the library function, they should have made a bug. Okay, if they make a bug, the submarine starts emitting radiation, or if some problem comes, I must be responsible. So the people who are doing engineering, they are responsible for the design also. So we must be knowing how it is working also, and whenever there is a problem, you have to check how it is working. Yeah, sometimes purposefully also the limitations of that built-in functions will be there. For smaller job, built-in functions will be doing fine. For some constraints, it may not work. But when we do, yeah, it should be a difference between a driver and the automobile engineer. Driver also will use the car. Automobile also, engineer also will use the car. Who will be efficiently driving? Driver will be efficiently driving up to the time problem comes. Okay, when problem comes, automobile engineer is done. So this is the simulation for the same algorithm. You can see this, that will be sufficient. But I have taken a small example I simulated with. Finally, they will return the value of R1, I think, R1, yes, R1. So 7 is the greatest common divisor between 161 and 128. 7 is the greatest common divisor between 161 and 128. Next day also I am going to mathematics only. Field. Okay. In cryptography, there will be one algorithm that AES algorithm. In that AES algorithm, they are using a field called Calais field. In the Calais field, they use a polynomial. Using that polynomial only, we are going to choose a key. So choosing the key is very important for the security. For choosing the key, you have to follow that equation. That equation is based on Calais field. So we will understand what is meant by field, group, ring, field, etc. You should have studied in 12th also. Even in BTech also, you should have studied in discrete maths. But I will explain once again. So this AES algorithm and the elliptic curve cryptography, both are using finite field only. These two algorithms only, most powerful algorithm. In symmetric cryptography, AES algorithm is the powerful one. In public key cryptography, elliptic curve cryptography is the most powerful algorithm. These two algorithms both are using finite field. So, field is a subset of ring, and that is a subset of group. So, we will start with group, then go to ring, then go to field. After that, finite field. You see the structure. The superset is group. The group will be satisfying 4 properties. First, you have to start with algebraic structure. A non-empty set G with a binary operator star is said to be a group if it satisfies 4 axioms: closure property, associative property, inverse existence, and identity existence. These 4 properties are satisfied means it is a group. Now, in addition addition to these four properties, if it is satisfying commutative property also, that is called abelian group. After that, for field with respect to multiplications, some property with respect to addition properties, including distributive properties. Distributive properties, A into B plus C equal to AB plus BC. That property also to be satisfied, then it will be field. Then, first, abelian group to ring to commutative ring. Commutative ring means it will be multiplication also will be commutative. Then, integral domain. Integral domain is commutative ring with unity. And field with unity and inverse also. That will be field. And finite field, it will be satisfying a modular group. So these are all the algebraic structures that we will be using in cryptography. First, that finite field, alloys field of 2 power n, that is the most important finite field in cryptography. We start from abstract algebra. These are the axioms for group. Can you say the cube roots of unity with respect to multiplication forms a group? You heard about cube roots of unity? Or I will take a simple example. Set of integers with respect to addition will form a group. Set of integers with respect to addition. Will it form a group? Yes. What will be the inverse of plus 5? What is the additive identity? 0. So it forms a group. With respect to multiplication, will it form a group? Set of integers? No. What is the multiplicative inverse of 5? 1 by 5. Is it available in set of integers? No. So it is not a group. Similarly, in real numbers, it can form a group with respect to addition with 0. With respect to multiplication, other than 0, if you take all the floating point numbers, it will form a group. And cube roots of unity with respect to multiplication, it can form a group. Everything you can do with the composition table itself. For example, if I am drawing the composition table, you multiply 1 into 1, 1. 1 into W, 1 into W would be W. 1 into omega square, omega square. Omega into 1, omega. Omega into omega, omega square. Omega into omega square, omega cube will be equal to 1. Omega square into 1, omega square. Omega square into omega, 1. Omega square into omega square, omega. Since it is omega cube into omega, omega cube is 1. I have formed the composition table. From the composition table, the multiplication of any two numbers is belonging to the same group. That means it is satisfying the same set. Therefore, it is satisfying the closure property. Next, the associative property. You take 1 into omega into omega square. It will be equivalent to omega cube, that is equal to 1. So, associative property, if you change the bracket or the order of multiplication, it is going to be the same thing. So, it is associative. What is the identity element? If you multiply with something, you will get the same thing. 1 is the identity element. What is the inverse of omega? Omega into something gives 1. 1 by omega is equal to omega square. The reason is omega into omega square equal to 1. That means the inverse of omega is omega square. The inverse of omega square is omega. Therefore, inverse also exists. Identity exists, inverse exists, closure property satisfied, associative property satisfied, therefore it is a group. You see the axioms, 4 axioms, closure property, associative property, identity element, inverse. These 4 properties are satisfied, it is closed. Will it satisfy commutative property also? You know what is commutative property? A star B equal to B star A. So multiplication 1 into W equal to W into 1, or W into W square equal to W square into W. All are satisfied. Therefore it is an Abelian group. A group, order of a group. If a group has finite number of elements, it is called a finite group. If a group has infinite number of elements, it is an infinite group. So I have shown one group with cube roots of unity. It is finite group or infinite group. How many elements are there? With that 1 omega omega square. How many elements are there? Only 3 elements are there. So the order of the group is 3. It is a finite group. To take the set of integers with respect to addition, it forms a group. So it is an example of infinite group. You see the definitions here. If a group has finite number of elements, it is referred to as a finite group. And the order of the group is equal to the order of elements. Otherwise the group is called infinite group. If I put addition modulo 5, okay, addition modulo 5, if I form the this one composition table. Addition modulo 5. Addition modulo 5 I am taking. I am going to add 0 plus 0, 0 plus 1, 0 plus 2, 3, 4. Here 1, 2, 3, 4, 5 mod 5, 0. Here 2, 3, 4, 0, 1. Here 3, 4, 0, 1, 2. Here 4, 0, 1, 2, 3. This group is finite group or infinite group? Will it form a group first of all with respect to addition modulo 5? We can do for multiplication modulo 5 also, but I am doing it for addition modulo 5. What is the identity element? 0. This is the inverse of 5. Sorry, inverse of any element. Let me take 3. What is the inverse of 3? 3 plus something should give 0. So what is the inverse of 3? 3 plus something equal to 0. No, minus 3 is 2. Minus 3 is equal to 2. Minus 3 plus 5. Minus 3 is equal to minus 3 plus 5. It is equivalent to plus 5 also once again. So minus 3 plus 5 is 2, 7, 12, 17, all are equivalent only. So minus 3 is also correct, but it is 2 only. What is the inverse of 4? 1. So we find inverse. So identity element is that inverse is that we can prove the associative law, we can closure property is known from the table, therefore it is a proof. So addition modulo phi, addition modulo m, addition modulo n, these are all proofs. Is a finite proof or infinite proof? Finite proof. What is the order of this proof? 5. 5 elements are there. What are the 5 elements? 0, 1, 2, 3, 4. 5 elements are there. So some of the familiar groups are signal has come for lunch. I will be drawing only 1 or 2 slides. After that we will break for lunch. You see familiar groups, set of all integer under addition, set of rational numbers under addition, real numbers under addition, complex number under addition, integer modulo n under addition. Suppose you take complex number. Addition of 2 complex numbers will be another complex number or not? Yes, closure property. And suppose we have a plus ib. What is the inverse of a plus ib? Minus a minus ib. You add a plus ib with minus a minus ib, what will be getting? 0. What is the identity element? 0 is the identity element. You can write 0 plus 0 I. That is only. So set of all complex numbers under addition forms a group. Multiplication non-zero you have to take. Suppose you take 0 also. For example, pi 1 by pi you can take. Minus 7, 1 by minus 7 you can take. 0, 0 by 0 is 1. So that is a non-zero. Cyclic proof means there will be a generator. For example, for pi is a generator means pi power 1, pi power 2, pi power 3. By that we have to go on. When modulo pi it is there, pi power 1 modulo pi will be how much? Pi mod pi, 0. Pi square mod pi, 0 like that will come. So the modulo also with the powers inverse will be there, not be there. Two questions are there. This is an example of a group for multiplication. Multiplication modulo pi. I did not take 0. From where I have started? 1. Pi. Take pi and pi. That is 4 and 4. How much is coming? 4 4s are 16. Odd pi 1. So the last line you are putting 1. This is multiplication modulo 8. This is a cipher called affine cipher. In this, suppose you are given an x is the plain text, you will be getting y as the ciphertext. Here there will be 2 components for the key, a and b. Ax plus b is the algorithm. So a is the component of the key, b is the component of the key. You have to find both a and b to know the key. Suppose you are given some x equal to 4, y will be known if you know A and B. Suppose they are given some A and some B, you can find Y value. But if you are knowing only hypertext values, you want to know the plain text value, you have to solve the equation. So 22 and 7 are the hypertext values, Y values. You don't know the X value. To find the X value, you have to solve the equation. Solving the equation, first subtracting equation 2 from 1 and getting minus 15A equal to 15 mod 26. This 15 equal to 11. Minus 15 equal to 11. You see minus 15, I am putting minus 15A equal to 11A. How it is 11A? Mod 26 value. So minus 15 is equivalent to 11. That way, if you put 11A equal to 15 mod, that means 11 inverse you have to find. Now 11 inverse in some way, if you find 11 inverse into 15 equal to 26, and 11 inverse if you find it is 19. I told you how to find the inverse. 11 inverse how to find in mod 26 is 11 into something equal to 1 mod 26. By that if you find 11 into 19, if you take how much it is coming? 11 into 19 is 190, 209, 209 mod 26. If you put 209 mod 26 will be 19. So once you know 19, A equal to one value if you know, then you can substitute in the other value 19 mod 26 equal to 25. Once you know the inverse, A equal to 19 into 15 mod 26 equal to 285 mod 26, that is equal to 25. So A equal to 25 you know, B equal to you can find. Once you know A and B, you can find A equal to 25, B equal to 0. You can find X value from Y. In this way you can take it. This cipher is called affine cipher. So the classical cryptography, many algorithms are had. Caesar cipher, Bigneri cipher, Playfer cipher, Hill cipher, affine cipher. 5 algorithm I have. So this 5 algorithm, affine cipher, it needs 2 keys, 2 components of A and B. So to solve two simultaneously.